Hello, precalculus class. Today we're going to learn about the conic section, the hyperbola. But to start, go ahead and try this warm-up problem. You can stop the video here. All right, so after completing the square, we end up with this equation here. X minus 2 quantity squared over 3 plus y plus 1 quantity squared over 2 equals 1. I should say first though, right away you know it's an ellipse, and the reason why you know this is the coefficient of the x squared term is 2 and the coefficient of the y squared term is 3. These are both positive numbers and they are different numbers, so we know it is an ellipse because they are the same sign but different. Now we can talk about the key information on this conic and draw a quick sketch of it. First of all, I know the center is at 2, -1. I know that A is the square root of 3, which is approximately 1.7, and B is the square root of 2, which is approximately 1.4. We can also find C by doing A squared equals B squared plus C squared. So 3 equals 2 plus 1. C squared is 1, so C is 1. So let's go ahead and graph it. We know it's a horizontal ellipse because A, or the larger value, A squared is 3, and that's under the x term. So let's plot our center at 2, -1. And then we can plot the foci points. They're 1 away, so here's a foci, here's a focus. And then our vertices are root 3 away from the center, so just about 2. Here's a vertex, and here's a vertex. And then our minor axis is 1.5 away in each direction, 1.5 away. So it's very circular since A and B are so close. And there's our ellipse. That's about it. I guess we could also list the actual foci are at 1, -1, and 3, -1. All right, now we're going to learn about the hyperbola. Once again, we have the general equation here, and we're focused on the equation without the bxy term, which rotates the convex from not being horizontal or vertical, and we're going to be talking about the hyperbola today. Notice that the hyperbola, there's horizontal and vertical equation differences, but they're pretty much the same standard forms as the ellipse, but instead of a plus in the ellipse, it's a minus. The other thing is the a squared is either under the x term or the y term. If the a is under the x term or the x term is positive, it's a horizontal hyperbola. And if the y squared term is positive, it's a vertical hyperbola. You can tell something's a hyperbola right away by looking at your coefficients of your x squared and y squared terms, as long as they are different signs, which means their product is negative. So it says a times c is less than 0 or negative. So if it's different signs, doesn't matter their values, but if it's different signs, then it is a hyperbola. Here is your definition of the hyperbola. A hyperbola is the collection of all points in the plane, the difference of whose distances from two fixed points, called the foci points, is a constant value. This is really similar to the ellipse. In the ellipse, these two distances, their sum was fixed. Here, their difference is fixed. So you can see these two curves here, and there's a symmetric one on the other side, constitute the hyperbola. If I pick any point on it, like let's say I choose this point here, and I look at the distance from this foci point, and I subtract this distance, I get the same number every time, and that number is 2a. Once again, there's 3 key values that we're going to be looking at, a, b, and c, and the a here, which is your distance from your center to the vertex, is the same a, and this 2a, that's your fixed distance, the difference of which is fixed. This is a picture of a horizontal hyperbola because the transverse axis, which connects the foci, the vertex, and the center, is a horizontal line. If we had a vertical hyperbola, then it would look something like this, opening up and down around the focus points, and the transverse axis, of course, in that case, is a vertical line. Let's look at the equation. Actually, I want to keep the picture on there. So you can see now a hyperbola with center at the origin and major axis coinciding with the coordinate axis is shifting horizontally h units and vertically k units. So the center, once again, is at the point hk. Notice a couple other things that we'll talk more about in the graph. We have the transverse axis is the one connecting all those key points here. And then we have something called the conjugate axis, which is like your minor axis in the ellipse. And you might even want to just think about the fact that a hyperbola is like an ellipse turned out about itself. So I'm just going to kind of draw an ellipse here. But if you take that ellipse and flip it out, you kind of get the hyperbola curve, although it's a very different shape of a curve. There's also something called an asymptote in your graph, and the asymptote is very important for when you're drawing your hyperbola, because an asymptote is like a boundary line. It's something, or it's a limit where the curve will approach it but never touch it. All right, let's go ahead and look at the equation for the hyperbola. So here you have the horizontal hyperbola, and you can see that the x squared term is positive and the y squared term is negative. And the vertical hyperbola, where the y squared term is positive and the x squared term is negative. Once again, there's a relationship, a Pythagorean relationship between the three values a, b, and c, c being the distance from the center to the foci. In this case, and I'll go back to the picture of the graph in a minute, c is the largest value, so it turns out that c squared is equal to a squared plus b squared. If you recall in the ellipse, a was the largest value, so it was a squared equals b squared plus c squared. Let's just take a look again at the picture of the hyperbola so you can see that. So note in this picture here, the c distance here is the longest distance. It's much longer than a. So that turns out to be the same distance right here. That's your c distance, and you can see the right triangle, your a squared plus b squared equals c squared. So I just always remember which is my longest length. That's the squared that equals the sum of the other two squareds. And you're going to need that to solve some problems. All right, let's look at some examples. Our first example is to graph and identify key facts about the hyperbola below. The first thing you want to see is that your a value is -1 and your c value is 4. So one is negative and one is positive. You immediately know, since they both exist and they're different signs, that this is a hyperbola. Okay, why don't you pause it here and complete the square, and then we'll unpause it together and you'll see the answer. All right, take a look at what happens. So the first thing I did was I started with the y squared term, since that is positive. And I pulled out the 4, and it takes a 4 to complete the square, so I'm adding 16. And then I take the negative term, which was the x squared, and I actually pull out the negative. So I end up with x squared plus 2x, and I need a 1 to complete that square, but what I really added was a -1. When you go through the simplification there and get your binomial squareds, you have 4 times y minus 2 squared minus x plus 1 squared equals a positive 4 on the other side. Well, we need it to equal 1, so I divide both sides by 4, and you end up with this equation here. This is your equation of the hyperbola. Note, a is less than b. 1 is a squared, so a squared equals 1, so a is 1. B squared equals 4, so b is 2. And that can be the case. You can have a hyperbola that is vertical, but the vertical transverse axis is smaller than the horizontal conjugate axis. So the values of A and B, there's no requirement that A be bigger than B. The key here is that C is the largest term. So let's just calculate C real quick. C squared equals A squared plus B squared. So it means C squared equals 5, and C is the square root of 5, which is approximately 2.2. Okay, now that we have that information, we can draw ourselves a graph. So let's give us a little space, and we'll go ahead and draw a coordinate plane here. All right, so the center of this hyperbola is -1, 2. Don't forget the x is with the x coordinate and the y is with the y coordinate. So let's plot that first. So -1 up 2. And then since we know the y squared is positive, this is a vertical hyperbola. So let's just write that down, vertical. And that means the transverse axis is a vertical line right at x equals -1. So I am going to walk 1 up, and that is the vertex, and 1 down. That means B is my conjugate axis, so I'm going to mark B spaces right and left. And I'm going to create a little box here. This box gives us the corners, or the corners of this box will be our asymptotes to help us draw in. We know these 2 points here are your vertices because it's going to open up and down. I'm also going to plot your focus points. So let me go ahead and do that. So that's up 2.2 and down 2.2. So about here is a focus, and 1, 2, about here is a focus. So the curves go up around that. Now, how do I draw in those curves? Well, what I'm going to do is draw in the asymptotes. So the asymptotes connect the corners of these boxes, and these are our boundary lines. And now I know that my hyperbola starts at the vertex, goes up around that focus point on both sides, and gets closer and closer to that asymptote as it moves away from the vertex. So same down here, and they're symmetric. And there we have it. Now, something that you should also be able to write down is the equation of those asymptotes. So these lines, you can think about slope, right? Slope is rise over run. So we know our rise is our A in this case, and our run is our B. So I'm going to use point slope form. So I'm going to use the point that's the center. So I write y minus 2 equals my rise, which in this case was A, which is 1, over my run, which is 2, and then x minus the x coordinate of the point, so plus 1. Now that's the slope of the that's the asymptote equation that's increasing, and of course I can put that into slope-intercept form, but I'll just leave it. And here is the one that is decreasing. It's going through the same point, and its slope is the same magnitude, but it is negative. It's coming down. So these are your equations of your asymptotes using point slope form. And there you have it. There you have the center, the values of A, B, and C. You can also write down what the focus points are, and you have your asymptotes. All right, here's another example. This one, you're asked to find the equation of a hyperbola with the center at 2, -3, one focus at 5, -3, and one vertex at 3, -3. So in order to do this, the best thing to do is to draw a graph. So I am going to give ourselves a coordinate plane here, plot our center, plot the focus point, so 5. Let's label that focus, label that center, and then a vertex at 3, -3, and label this vertex. So these key points are on a horizontal line. So this is a horizontal hyperbola, and you can see that it's going to come from the vertex out and around the focus point. although I'm not really going to draw it yet because I need to get my asymptotes in there. All right, but what we can do is we can write down our equation, some of the key pieces of information. Since it's horizontal, it's going to be x minus the x coordinate of the center over a squared minus y minus the y coordinate of the center over b squared equals 1. So let's write in that key information. So our center is at 2, -3, so it's -2 plus 3. We know that A is 1 because that's the distance from the center to the vertex. So that means this here is 1. And we know that C is 3 because that's your center to the focus. So now I know that C squared equals A squared plus B squared, and 9 equals 1 plus B squared. So B squared is 8, which is 2√2. So we can replace the B squared here with an 8. Great. We can also draw our hyperbola, because now that I know that B is 2√2, which is about 2.8, I can plot that. So from the center, I'm going to plot my other vertex. I'm going to plot my other focus. So that's 3 away. We are going to go up and down 2.8 on your conjugate axis. Draw ourselves a little rectangle here. Draw in our asymptotes, which are much taller and narrower. We'll write their equations in a moment. And then we can draw in our hyperbola. So the hyperbola comes from the vertex out towards the asymptotes. Boy, I made this quite messy. I apologize, but hopefully you can get the idea. And you can see that it's opening horizontally. All right, let's write down the equation for those asymptotes, kind of the final step we need to do here. So I'm going to write it in point slope form. So it's going to be y plus 3, since my point is going to be my center, to -3. And then my slope here, I can't just assume it's a over b, it's rise over run. So rise over run. My rise is my b in this case, so it's plus or minus, plus for the increasing asymptote and minus for the decreasing, 2√2. That's your square root of b, or your b value, divided by 1, because that's your a value, so you didn't even need the over 1, and then x minus 2. And that is the equation of your asymptotes and your graph, and your equation of your hyperbola. One more example. All right, in this last example, you're given the graph of a hyperbola and you're asked to write the equation. So the first thing you should see about this hyperbola is it's opening up or down. That means its transverse axis is a vertical line, and this is a vertical hyperbola. So I'm going to identify my ordered pair for my center. It's at -5, 4. So I can start that part of this equation right away. So your y term comes first since it's vertical, and you're going to have y minus 4 squared minus x plus 5 squared equals 1. Now we just have to find our a and b values. So a is the distance from the center to the vertex on the transverse axis. And let's see. That is, this looks like it goes down 1 here. So that value is up 4 and down to here. So a is 5. And it's going from 4 to 9. So a is 5. So that's a 25. Let's just write down a is 5. And b, we can see it's crossing here at -1, and it was at -5. So b is 4. Now you might be getting a little confused because the scales are a little bit off. You can see it looks like they're both the same. It looks pretty much like a square, but you really need to look at your coordinates to make sure that you're getting these distances correct. And it just so happens that the center is at 4 and -5, and A and B are 4 and 5 too. They don't have to align like that. But so b squared is 16, and we have our equation. What if I said, hey, where's the focus points? We know they're somewhere down here and up here, but we need to find the c value. So c squared equals 25 plus 16. C squared equals 41, and c is the square root of 41, or approximately 6.4 up and down. So our focus points, we could write them down. They are going to be over at -5, and they're going to be at the center 4, but plus or minus the square root of 41. So that's your focus points. And we can also write down the equation of the asymptotes, once again, in point-slope form. So it's going to be y minus 4 equals plus or minus rise over run. So we can see our rise is 5 over our run of 4. And then we have x plus 5. So we have the equation of our hyperbola, the focus points, the center point, and the equation of the asymptotes. That's it. Good luck on your homework, and we will be going over this again as needed.